Hello and good time of day to you. I've retrieved this TEAC A-R600 amplifier from the bottom of a cupboard where it had been stowed away for a long time. I know it doesn't work, but I can't remember anything about the nature of its fault. Before taking the cover off, let's have a quick look at some pages from its service manual for an overview of how it works and what we should expect to find inside. Let's start with this block diagram, in particular the power supply section here on the right. The mains input is here and is connected to the manually operated front panel power switch here. When that switch is on, power is applied to this miniature transformer, which via a regulator produces a 5-volt power supply rail, which is for the microcontroller. Power to the main transformer is controlled by this relay. That transformer has 3 secondary windings and is used to generate 2 unregulated balanced power supply rails and regulated plus or minus 15 volt and a 5-volt power supply rail. The signal inputs are shown here on the left. A bit unusually, this amplifier has a microphone input, and the amplified signal from that is mixed in with whatever main source has been selected. This is a digitally controlled switch IC, and it deals with selecting the desired source and also the tape loop inputs and outputs, and it feeds whatever source is selected to the main volume control. A small electric motor is connected to that control, and that's driven by the microcontroller. This allows the volume to be adjusted using the remote control. There's a separate preamplifier stage here. There are treble bass and balance controls, and they can be bypassed by this switching IC here. This represents the main power amplifier section, and its output is fed via another relay to the loudspeakers. There's also something marked here overload detector. I imagine that monitors the output for something such as excess DC offset or excessive current through the output transistors, and if it detects a problem in that area, it disconnects the loudspeakers by switching off this relay. There's this wiring diagram, which no doubt will prove very useful when trying to work out how everything is connected together. The circuit diagram is spread over a couple of pages. Here is one of them. The signal inputs are shown here on the left. This is the source selection switching IC. Power supply circuitry is over here. These are the preamplifiers, both channels are shown, and this is the main power amplifier section. Again, both channels are shown. Here's a zoomed in view of the power amplifier section. Again, both channels are shown, so we need only bother looking at one of them. I've not studied this circuit in much detail, but I can pick out the general signal path and approximately how it must operate. The input arrives here at a FET differential pair. This section here must be responsible for the voltage gain, and this transistor sets the bias for the output stage, and that can be adjusted using this variable resistor here. These are the final output transistors, a fairly standard NPN-PNP push-pull pair, and via a switching relay or two drive the loudspeakers. This circuitry here must be to do with monitoring the output. In particular, I can see that this transistor is looking at the voltage across this emitter resistor here. Not sure what this does yet. I'll have a look at that later if I need to. Negative feedback is provided from the output through this resistor and capacitor network through to the other input of the differential pair. This is the other page of the circuit diagram. It shows the microcontroller, a set of transistors that drive the source display LEDs on the front panel. Various other little sub-circuits are shown on here, for example the tone controls here and the microphone preamplifier. This is an even closer view of the power amplifier circuit. Here's the filter network in the feedback path that I pointed out previously. I hadn't been looking at this for very long, and my attention was suddenly drawn to this capacitor here. At first glance, one might think that provides positive feedback at higher frequencies, but of course that doesn't make much sense. And while I haven't analysed the frequency and in particular the phase performance of this filter network, I expect that once that's been accounted for, and any other phase shifts due to stray capacitances and inductances on the circuit board, that this capacitor in fact provides negative feedback at high frequencies. I have a suspicion, but of course I can't prove it, that that capacitor did not feature in the first design of this circuit, but was added later to increase stability and probably reduce the risk of this amplifier going into high-frequency oscillation. Here's what's inside, viewed from the rear. Most of the circuitry is on the main base PCB, but there are a few other circuit boards scattered about, and the front panel controls and microcontroller are on this board here at the front, which you can only see the rear of. The mains power input arrives at this small board here. Just peeking out here is the small transformer that's responsible for the microcontroller's 5-volt supply. The mains then passes through these blue wires to and from the front panel power switch, and through this relay that's operated by the microcontroller, before reaching the main large and heavy power transformer here. This small circuit here contains a buffer circuit which is connected to an output on the rear panel labelled remote control. I believe it's possible to connect certain models of tuner or CD player to this and have them operated via this device's remote control unit. Unfortunately, I haven't got the remote control, so I won't be able to test that function, nor the general infrared remote control receiving capability. Down here is the volume control. That can be operated by the knob on the front or by the small electric motor that's operated by the microcontroller. The microphone preamplifier is on this small circuit board at the front, and slightly strangely, its output is then fed over to this remote control circuit board that is also home to a mixer amplifier that combines the microphone signal with the main selected audio source. The power amplifier's output transistors are mounted on this fairly large heatsink. The two for one of the channels are here and here. Those for the other channel are on the other side. This smaller device down here is one of the transistors that sets the bias conditions for the output stage, and so, as is usual, it's mounted on the same heatsink, so it will be held at approximately the same temperature as the output transistors. The heatsink is hollow, and there's a fan that can blow air through the centre of it and out of a vent on the rear panel. Using a multimeter in its continuity test mode, I've made a few simple checks. First, I checked that there is a connection between the mains plug and the mains input circuit board at the rear. At a couple of the output transistors, I also checked for any short circuits between the main power supply rails or between them and the chassis. Had I found any such thing, then it probably would have indicated one or more failed output transistors, though of course there could be many other causes. I haven't got any signal source connected, neither are there any loudspeakers or headphones plugged in, but I'm going to just briefly turn the power on to see what happens. First the main power switch. The standby LED has come on, so that's a good start. Now I'll press the standby button and that should turn on full power to the rest of the amplifier. Almost immediately after pressing that button I heard a relay click, probably the one on the mains input board switching on the supply to the transformer. Then a few seconds later there was another click, probably one of the loudspeaker switching relays. I can see the LED underneath the label where it says tuner has come on. And turning the input selector dial does change that indicator light. So it looks as if the microprocessor and its power supply etc. at least is working. So now it's time to make a few more detailed checks. I've used this multimeter to measure the voltage on the main power supply rails at the centre lead of a pair of the output transistors. These are the supply rails labelled plus VCC and minus VCC on the block diagram, and the circuit diagram says I should find plus and minus 54.5 volts there. I found plus and minus 60 volts, so that's probably fine. However, while I was doing that, I suddenly noticed a very strong smell of overheating electronic components, so I immediately switched the power off. It didn't take long for the burning smell to lead me to its source, and it seems there are a couple of overheating transistors, one lurking back in the shadows here, and another one here, both in TO126 packages. I can also see that next to each transistor is a discoloured resistor, so clearly they've been overheating too. There are a couple more discoloured resistors in this area, down here, each next to another pair of transistors in exactly the same packages as the overheating ones. Now these two were quite warm, but not absolutely burning hot as the first two were. The overheating transistors are in the preamplifier section. They are Q411 and Q413. The discoloured resistors are not too surprisingly the emitter resistors associated with these transistors, R425 and R427. You'll note there are two copies of this circuit, one for each channel. The equivalent resistors down here are also discoloured. This circuit is powered by the unregulated plus and minus 30 volt supply. I've measured these rails in this circuit, and it looks as if the supply is working properly. However, I measured approximately 8.6 volts across each of these resistors. For a 56 ohm resistor, that means the power dissipation in the resistor will be about 1.3 watts, and just by looking at them, I can tell they're not designed for that, so it's no wonder they're looking a bit cooked. Down here, I measured only 38 millivolts across this resistor, and no voltage at all across here, but because these resistors are also discoloured from heat, it's clear something has gone wrong in the circuit for this channel too. It's slightly difficult to read, but I think this text here indicates that the voltage at the base of this transistor should be minus 0.5 volts, and that makes sense as I should think the output should normally sit around 0 volts. I measured minus 5.5 volts, which doesn't seem quite right, and down here at the equivalent point in the other channel, I measured minus 29.7 volts, which I definitely think must be wrong. It's a little bit difficult to get to all of these components with the main PCB still installed in the chassis, and unlike some amplifiers I've worked on, there is no rear removable panel that will let me get to the underside of the circuit board. So I think I'm going to have to remove the main PCB, which means more or less completely dismantling the entire amplifier, so that I can remove some of these components and test them properly. However, before I do that, I want to try to find out whether the only fault in this amplifier is in the preamplifier section. Given the way it's constructed, I can fairly easily unplug the input to the preamplifier here and unplug its output here. That means I can inject a test signal at one of the inputs and see whether it reaches this point, thereby testing the input and switching stage. I can then inject a test signal here and test all of the rest of the circuitry and see whether the signal makes its way to the loudspeaker outputs. This is the volume control circuit board. Audio signals enter it via this connector here and exit it through this one. On the circuit board, the contacts are labelled L, G, R, G and 5 volts. They're connected via this bundle of cables down to here, where the contacts are labelled from left to right R, G, L, G and 5 volts. The wiring of this interconnect is a little bit strange. It's as shown here. If the labels are to be believed, then it suggests that the right and left-hand channels are swapped. I assume the letter G stands for ground, and I verify that in all cases these contacts are common with the chassis, and that R and L must mean the right and left-hand audio signals. Also, the screen and core of one of the interconnecting cables are wired the wrong way around. This must surely be a manufacturing mistake, though I don't think it should cause a serious problem. Down here, the contact labelled R connects to one side of resistor R401, and that's labelled with an L on the circuit diagram. And similarly, the contact that's labelled L connects to one side of R402, and that's labelled R on the circuit diagram. So either the circuit diagram or the silkscreen on the circuit board is incorrect. At this point, I haven't broken any of the connections between the various circuit sections. I'm using a signal generator to feed a 1 kHz sine wave into both of the connectors labelled CD on the rear panel. If I touch the probe to the inside of one of those connectors, then you can see that signal on the oscilloscope. Its amplitude is approximately 200 millivolts peak to peak. Now I'll turn the amplifier's power on and connect the probe to the input on the volume control board, the one that's labelled with an L. And I note the source selection LED on the front panel is indicated that the tuner input is selected, so I'll turn the control until the CD LED comes on. And indeed there is our sine wave. I'll move the probe over to the input labelled with an R, and there's the signal again. So it seems the input selection circuitry is at least mostly working. I'll now try looking at the signals at the output of the volume control board. This is the one labelled L. If I turn the volume control, its amplitude varies. I'll repeat that for the output labelled R. The signal is present here too. I'll adjust the volume control. I note the adjustment is far more abrupt for this channel. The signal almost completely disappears as soon as I turn the control away from the maximum setting. That could be due to a problem in the control potentiometer, but I suspect it's more likely because the output is being loaded by the input to the preamplifier. From this connector, the signals go down this bundle of cables to the input to the preamplifier. The output from that section is on a connector down here, which is a bit difficult to get to, but they're carried on this bundle of wires up to the front panel circuit board, where they pass through the tone and balance controls. So I'll try to connect the probe to them at this point because they're labelled on the rear of that circuit board. This is the preamplifier output that's labelled with an L on the front panel board. So the test signal is present there, and with a very large amplitude. I'll adjust the volume control. It looks as if that channel of the preamplifier is working and has quite considerable gain. I'll now move the probe to the preamplifier output labelled with an R. That's it there. There's a considerable DC offset and no sign of the sine wave. There it is. I've just turned the volume control to maximum. I'm having trouble keeping the probe in place. There it is, but clearly the signal is badly distorted. I've disconnected this plug here. It carries the output from the tone and balance controls, which follows the preamplifier and volume control. Normally it feeds the signals down to this socket here, which is the input to the power amplifier. Instead, I've connected these wires so I can inject a sine wave from the signal generator. The right and left loudspeaker outputs labelled A on the rear are connected to the oscilloscope, and this time the vertical scale is 50 volts per division. The amplifier is on, and I'll now turn up the amplitude control on the signal generator. Both channels can produce about 100 volts peak to peak before clipping. That of course is with no load connected. The only major part I haven't tested are the tone and balance controls. However, it's looking likely that the only fault in this amplifier is in the preamplifier circuit. Unfortunately, I've got some other work I must complete first, so I'll have to put this aside for a while, but I'll report back to you when I continue.